We'll proceed in vector algebra and calculus. Vector algebra and calculus. So this is the topic that we are pursuing. Vector algebra and calculus. So in this scenario of vector algebra and calculus, what we are trying to find is the curve length. Okay, people would say that it is not that is something very important to me, but it is very important. If someone trying to find the curve length means he is doing kind of too many things in the okay. So if he is okay, if he someone is trying to find the curve length, then knowingly, unknowingly, he is doing churning. He is doing churning in the vector, algebra, and calculus altogether. So finding the curve length is very important. Now we have found the curve length. We have found the curve length through two methods. One is primitive calculus and one is modern calculus. Modern calculus where we try to find everything through delta x and delta x tends to 0 and this is how we do our work. Primitive calculus there is no delta x. It is purely based upon the integral calculus and integral calculus calculates the area. Integral calculus does the addition or does the multiplication by calculating the area. Rather, I would say by doing the by doing the okay. Rather, I would say by doing the calculating the area. Integral calculus it calculates the net addition. Many times I have talked about it. What do you mean by net addition? Net addition, as I say, if someone is collecting orange every day someone is collecting orange, one or two orange every day. At the end of 10 days, how many oranges he is collecting? 2 into 10 is the multiplication. Otherwise, addition is 2 plus 2 plus 2 plus 2 plus 2. Okay, that is 10 times, that is also 20. Okay, but what about calculation of this addition 2 plus 2 10 times, that is 2 into 2 through area? Now, if I have a rectangle, if I take rectangle whose one side is 10, other side is 2. Rectangle whose one side is 10 and other side is 2. This is what it is, right? Someone is collecting, okay, someone is collecting oranges and 2 oranges per day. At the end of 10 days, how many oranges are there? Then consider one rectangle whose width is 10 and height is 20. Now take one rectangle whose width is 1 and height is 1. Small rectangle. Now place inside the rectangle. Now count it how many they are. That is area. Area is never width into height. That is wrong way of calculating the area. Width into height equal to area. What about area of a triangle? No. Then it is not width into height. It is width into something else. What about the whatever you are doing? It should be generic, right? That is the concept. If I say just adding every item give me the net addition, then it should be generic, right? If I get first day I get one orange, second day I get two oranges, third day I get three oranges. How many oranges I get? 1 plus 2 plus 3. First day I get two oranges, second day two oranges, third day two oranges. How many oranges I get? 2 plus 2 plus 2. Means addition works in any form. Just make plus plus. This is generic. This is generic. If I say I'm getting two oranges for 10 days, 2 into 10, multiplication is generic. If it comes in that fashion. Similarly, area should be generic. What is area? Breadth into height. No, that is area of only rectangle. Breadth into height cannot be area of all the two-dimensional shape. Then what is generic way of area? The generic way of area is take a two-dimensional shape and take one cube, one square, width is 1 and height is 1. Place inside the area. place inside the area that small sub-rectangle. And when it is filled, now count it. How many are they? That is the area. Area is nothing but that is one unit by one unit, one square is there, placed in the circle, and then whatever the number you count, that is the area. This is generic way. Like if someone is collecting one orange first day, second two orange next day, three orange next day, four orange next day, five orange next day, then how many oranges he is calculating? If this is x-axis, then first day the height is 1. There is a square, height is 1. Next day 1 to 2, if it is x-axis, 1 to 2, height is 2. 2 to 3, height is 3. There is a staircase. Staircase is going like this. Okay. Now calculate the area of this staircase. You get the net collection. So first is 1 into 1, that is 1. Next is 1 into 2, that is 2. Next is 1 into 3, that is 3. Next is 1 into 4, then it is 4. Don't make fun. This is funny, but funny is the truth. Okay, this is a staircase. Consider how many oranges are collected, how many days are there. Or instead of days, I would say per second. Once first second, one orange is getting collected. Second, two orange is getting collected. Third second, three oranges is getting collected. Fourth second, four oranges are getting collected. In that sense, how many seconds are there? There is 10,000 seconds. 10,000 seconds. Then it won't be a staircase. It will be like a straight line. Okay, if it is a straight line and this is x-axis, then this straight line will have one equation. So area is nothing but if you take a small square, place it, but how many someone would place? Anyway, now the integral calculus, the area fundamental, that is perfectly all right. To calculate the net addition, what you need to do to calculate the net addition, you have to place one unit by one unit, one square inside the area, and count it how many are there. That much is the net addition. 1 plus 2 plus 3 up to 1 lakh or 100,000 is the that is the net addition. What is other way? Other way of calculating the area, other way of calculating area is through calculus. What is calculus? Calculus is nothing but you start is kind of a generic way of calculating the area. If it is a rectangle, then area is, if width is x and height is k is constant, then area is k into x. Otherwise, the height is not constant. It is actually k into x to the power 0. K into x to the power 0. Remove the k. X to the power 0 into x is the area, means height is 1. If I have a rectangle, I am trying to calculate height. Generic way is place one unit by one unit square inside the area and calculate the, now count it. That much is the area or that much is the net addition. Okay, if that is the case, but mathematics is a way to find generic method or generic method. So generic methodology to finding the area is if height is 1 and width is x, area is 1 into x. No, area is x to the power 0 into x. Height into width. Let's consider now if height is x, first is height is x to the power 0 and width is x. That is height into width is the area. That is x. If height is x and width is x, what is the area? Height into width. Not true. Because height is x, width is x, area is not x, area is x square by 2. Because if I say this is x axis and this is height is x, height is not x. If height is a function over x, then height is actually x is a slant line rather than a straight line. If it is straight line, means it is a constant, means y is parallel to x axis. If y is x, then this is y. So if height is x and width is x, then their area is not x into x. But if height is x to the power 0, and width is x, then area is x to the power 0 into x. Or if height is k, then area is k into x. If height is k into x to the power 0, that is k, and width is x, then it is kx to the power 0 into x. Means height into width is the actual area of a two-dimensional shape, but only if it is a rectangle. Otherwise, just for just for sake of reliability, just for the sake of mental peaceness, I can say area of any shape is height by width, but it is an abstract notation, it is not real. Like if it is a triangle, then if width is x and height is function over x, and that is x, then if height is x, width is x, then area is x square by 2. Now I learned what is the area of any two-dimensional shape? Height by width. How come you can say like that? Yes, width is the independent x-axis, and height is dependent y-axis, and height is function over x. Okay, it is not function over x. Certainly, it is function over x. Yes, height is k constant. No, it is not function over x. Certainly, it is function over x. K into x to the power 0. Okay, so height into width is the area of any two-dimensional shape. Height is k into x, width is x, kx into x. But height is not kx square, it is kx square by 2 because it's a triangle. Okay, so I learned it. Okay, I learned it. So looks like if it is x to the power 0, then integration is x to the power 1 by 1. If it is x to the power 1, then integration means area. Integration means area. If x to the power 1, then area is x to the power 2 by 2. Looks like if it is x to the power 3, then area is x to the power 2, then area would be x to the power 3 by 3. Okay, if that is the case, then if it is x to the power n, then area would be x to the power n plus 1 divided by n plus 1. Makes sense, right? If it is x to the power, how we can say if it is x, then it is x to the power 2 by 2. Understood? If it is a triangle, then area is x to the power 2 by 2. Half of the, if this makes a rectangle, the triangle is half of the rectangle, x square by 2. If it is x square, then how you can say it is x to the power 3 by 3? Can you prove it? Yes, I can prove it. By integration by part. Please watch our previous videos. Integration by part is if I have fx gx, integration is fx, integration of fx into gx is fx integration of gx minus integration of differentiation of fx integration of gx. That is integration by part, that came from the product rule of differentiation. This many ways we have proved it, not one way, many ways we have proved it. Anyway, now consider fx gx. Fx is x and gx is x square. Then, I'm sorry, fx is x and gx is x. Then we are trying to get integration of x square. Fx gx, x into x. Integration is fx integration of gx, x into integration of x. That I know, x square by 2. It becomes x to the power 3 by 2. X integration of x is x square by 2. X to the power 3 by 2 is the integration minus big integration. Now differentiation of first one. Differentiation of x is 1 and the integration of second one, x square by 2. Now, now it becomes integration of x into x is nothing but x to the power 3 by 2 minus integration of x square by 2. This is what we are trying, right? Integration of x square, that is x to the power 3 by 2 minus integration of x square by 2. Take this on left side. It becomes 3 by 2 integration of x square, integration of x square. Integration of x square plus 1 by 2 integration of x square equal to x to the power 3 by 2. That is 3 by 2 integration of x square equal to x to the power 3 by 2. These proofs are not available anywhere else. Now, if that is the case, 2 gone. Integration of x square is nothing but x to the power 3 by 3. Okay, so consider supporting us. So anyway, now if that is the case, now integration of x square is x to the power 3 by 3. If you again take integration of a part, then you can calculate integration of x to the power 3, that is x to the power 4 by 4. Looks like we found a formula to calculate the area of any shape. Area of any shape whose one side is x-axis and another side is function over x-axis. Okay, for rectangle it is x to the power 0. For triangle it is x to the power 1, that is the height. Okay, for other it is x square, for other it is x to the power 3, like that. Then area is nothing but integration of the height. Integration of x square is the net area. Integration of x to the power 0 is the net area. Now to make it clean that what is integration of x to the power 3? X to the power 4 by 4, what it is? I don't know. I just said because I know it, x to the power 3 integration. X to the power 3 integration means there is a x-axis. There is a x-axis, and there is a y-axis. Y-axis is like this. Y-axis, x to the power 3 means y-axis is like this. If this is x-axis, y-axis is like this. Y-axis is like this. Then what is the area underneath it? If this is the y, if this is the y-axis, if this is the y, sorry, this is the y-axis, this is x-axis, what is the area underneath? That is integration of x to the power 3, integration of x to the power 3. Integration of x to the power 3 is nothing but integration of x to the power 3 dx. This is full form of integration. X to the power 3 multiplied by dx. Okay, if I remove d, then it becomes x to the power 3 into x. If x to the power 3 is the height, then height into width. We are trying to find the area with the height into width. But height into width, if I multiply, I would not get the exact area, so I insert d there. X to the power 3 into dx. Okay, now we use integral calculus. Integral calculus is nothing but simple, simple polynomial area only, right? What is there in integral calculus? So now it becomes x to the power 4 by 4. Okay, I understood. But what is x to the power 3? Why you are trying to get area to get the addition? That is, that is, consider I am collecting orange. First, second, I get one orange. Second, I get 8 oranges. Third second, I am getting 81 oranges. Fourth, I believe I am all right. Third second, I am getting 27 oranges. Fourth second, I am getting 64 oranges. Fifth second, I am getting 125 oranges. What are you talking about? This is how I am getting. Looks like you are getting in cube, x to the power 3. First second, you are getting 1. Second, you are getting 8. Third second, you are getting 27. 3 into 3 into 3. Fourth second, you are getting 64. 4 into. How many oranges I get at the end of 10 seconds? 1 plus 3 plus how much? 1 plus 8 plus 27 plus 64 plus 125 plus like that. Okay, if this, then it is like a staircase. The way I talk, it is like a staircase. But if it is too many seconds are there, it is like a straight line. If it is a straight line, then what is the net orange? Net orange collected is the area, or if it is a staircase also, first second 1, second 8, third second 27, like that. If you just calculate the area underneath it, you get the net addition. From there it started. Okay, now people understood that getting the net addition is nothing but draw a graph, whatever the addition you are getting, calculate the area underneath, you get the net addition. Now, to calculate the area underneath, that became a challenge. Then people started thinking about a generic solution. Then they found that if I know then they found that calculation of area is nothing but if it is a polynomial equation, then it is x to the power n by n plus 1. Now people went for notation. What is the area for any equation that is x to the power 3? If the net collection is function x to the power 3, the what we are saying, then what is the area from 0 to x? Then it is x to the power 4 by 4. How to denote it? How to denote it? So to give the notation, now people started thinking that area is nothing but width into height. At least pseudo way or abstract way we can write. Then here width is x and height is function over x. So fx into dx or dx is the net area integration. So this is how integration evolved. Now if I talk about differentiation, then it is other way. So differentiation is nothing but, okay, so differentiation, so integration is nothing but synonym of multiplication. Width into height is integration. Width into height is actually multiplication. So multiplication is also called integral calculus is also called synonym of multiplication. Okay, what is differentiation? It is synonym of division. If width into height, x into fx is the net area that is equal to gx. Fx dx is gx. What about gx by x or dgx by dx? Then you dgx by dx, what is gx? That is fx into dx. Dx gone, you get back the height. Integration is height by width, then differentiation is getting back the height. If integration is height into width is the integration, then differentiation of this with the width, we will get back the height. Fx dx is integration, then differentiation of fx dx is getting back the fx back. That is differentiation. But it has many different scenarios. A person, rather than, if he is saying he's collecting one orange. Now consider a person is walking. So first minute he is collecting 1 meter. Second minute he is collecting 1 meter. Third minute he is collecting 1 meter. This is what way he is walking. At this much only he is walking. Walking. That much slow he is. First minute he is collecting 1 meter. Second minute he is collecting 2 meter. Third minute he is collecting 3 meter. In the 100th minute he is collecting 1 second. First minute he is collecting 1 meter. Second minute he is collecting 1 meter. Third minute he is collecting 1 minute. 1 minute, 1 minute. Every time 1 minute span he is walking 1 meter only. If that is the case, then what is it his speed? What is, if I draw a graph? If I draw a graph, then how much he is collecting? Okay, then in the first first it is 0. It is 1, 2, 3, 4. This is the time x-axis. Then first second is collecting 1 meter. First to second, in that 1 second duration he is collecting 1 meter. Second to third he is collecting 1 meter. Okay, then how many meter he is collecting? 1 meter per second. Actually his velocity is 1 meter per second. If this is the velocity, now can you tell me at the end of x minute how much distance he has walked? So if I have velocity is nothing but d distance by dt. Distance by time is the velocity. Distance by time is the velocity. Why we go with algebra? Why we go with the calculus? We go with the calculus when region is not rectangular. If it is rectangular, then we can settle down with multiplication and division only. If it is region is rectangular, then I can settle down with the multiplication and division only. If it is not rectangular, then we go with polynomial way. Here, velocity is constant, and this is x-axis, this is velocity. It forms a rectangle. If it forms a rectangle, then what is the distance he covered at the end of x minute? Okay, what is velocity? 1 into x kilometer he has walked. So if it is rectangular, I can settle down in multiplication division only. But if it is not rectangular, then I have to try differentiation or differentiation and integration. Now consider person is first time duration 0 to 1 second he is walking 1 meter. 1 to 2 second he is walking 2 meter. 2 to 3 second he is walking 3 meter. Like that, between 11 to 12 second he is walking 12 meter. Okay, then looks like he has velocity of x. Earlier velocity was 1. Now velocity is x. x is the velocity. Means if n x velocity means x is time. Dependent upon the time, his velocity is changing. When time is 13 at 13 second, at that moment his velocity is 13 meter per, I mean, per minute we are saying, right? Per minute uh, he is covering 1, 2, 3, 4, 5, 6 meter. At the end, in the 30th minute, at that moment, he is in that 12th minute to 13th minute, he is walking 13 meter. This means that at the moment, that is 13th minute, at that moment his speed is 13 meter per minute. At a moment x minute, his speed is x meter per minute. Means speed is growing. If I draw a speed time graph, it will be like this. Now you tell me, when the time is any x minute, how much distance he has traveled. Okay, if I have velocity, the distance is integration of the velocity. If I have distance, then velocity is d distance by d time, as per the simple fundamental, right? Velocity is nothing but velocity is nothing but distance by time. Distance is nothing but velocity into time. Velocity into time. If it is a rectangular region, then it works. Velocity into time. If I am collecting two oranges daily, then if I draw a day graph, that two oranges daily, the height is 2 and it forms a rectangle. The net collection rate is 2 orange per day. At the end of x day, how much I have collected? Calculate the area of this rectangle, 2 into x. But if it is not rectangular, any shape other than rectangular, then we go by polynomial area. Then we go by integral calculus. Looks like integral calculus is very high-fi thing. It is very simple. It's a polynomial area only that we saw. Anyway, if that is the case, then if I have velocity is x, then what is the net distance covered? That is the area under it. That is the integration. Multi. If I have velocity and if I want the distance, then I have to multiply it with the time. Velocity into t, v dt. V, if it is not rectangular, it is not rectangular, right? It is triangle. Velocity is x. Then v dt, x dx, x square by 2 is the distance he covered at any time x. If x square 2 is the distance he is covering, if this is x-axis and x square is like this, if this is the distance he is covering at any moment, what is its speed? Dx square by 2 by 2, that is x. X is his speed. Okay, we are in a form in calculating the line length. This much dialogue I made to calculate the line length. Third way. One way to calculate the curve length, we saw primitive way. Next way to calculate the length of the curve is through modern way. There is a third way. Third way, if consider I am trying to calculate length of this line. I am trying to calculate length of this line. This is x-axis and this is y-axis. This is x-axis, this is origin. This is y-axis. If there is a line like this, y plus x equal to 3, what is the length of this line from y-axis intersection and x-axis intersection? Please talk in a plain way. What is the distance between 3, 0 and 0, 3? Tell me. Okay, if I connect 3, 0 and 0, 3, it is a line. What is the equation of line? Y plus x equal to 3. What is the equation of this vector? Okay, what is the equation of this vector? Okay, what is the equation of this vector? That is under question. Now, equation of this vector is I minus j. Please watch previous video to get the equation of this vector. How I get equation of this vector? That is I minus j. Okay, this is x-axis, this is y-axis. This is the line that is connecting 3, 0 and 0, 3. If this is the line, let's take any point here that is P. Any point here that is P. What is the coordinate for this point? X, y. The coordinate for this point is x, y. Now, this is x-axis, y-axis. This is origin. and this is the line. If I take, this is the line, if I take any point x comma y from origin, if I connect this x comma y and origin, this is called position vector. P vector. What is the equation of P vector? What is the equation of this P vector? Xi plus yj. P. What about dp by dx? Position vector, change in position vector with respect to time. If I talk about change in position vector with respect to time, the next what will come is called velocity vector. If I have a position vector and if I get that dp by dx, then it will again result in another vector that is called velocity vector. What is velocity vector? Velocity vector is dp by dx. What is dp by dx? That is xi plus yj, then dp by dx, that is called velocity vector, is I plus dy by dx j. I plus dy by dx j. I plus dy by dx j. Okay, if that is the case, then what it is? I plus dy by dx j. What is dy by dx? What is dy by dx? Then dy by dx, what equation of the line is y plus x equal to 3. dy by dx is minus 1. dy by dx is minus 1. If that is the case, then dp by dx is I minus j. dp by dx is I minus j. Okay, what is the direction of dp by dx? I minus j. What is the direction of dp by dx? Okay, I minus j. Okay, so dp by dx is I minus j. What is? Okay, what is the line? This is the line that is x plus y equal to 3. If I take any point P here, any point P here, this is the position vector, P vector. dp by dx is I minus j. That is along the line only. I minus j is along the line. This is I minus j. So vector, I can make parallel. This is I minus j. I minus j is along the y plus x equal to 3 only. This looks like if I differentiate the position vector dp by dx, then okay, I believe this fundamental I have given many times. Anyway, dp by dx is called velocity vector. dp by dx is called velocity vector. If I integrate velocity vector, I get back the displacement vector again. Makes sense, right? If displacement vector is xi plus yj, then velocity vector is dp by dx, that is I minus j. If I integrate I minus j, if I integrate I minus j, that is the displacement vector. I minus j, I would get back that velocity, sorry, position vector is xi plus yj. Velocity vector is dp by dx, that is I minus j. This is what we have seen, I plus dy by dxj. I minus j. If I integrate dp by dx, I should get back the p vector again, displacement vector again. If I integrate it with x, it becomes xi minus xj. xi minus xj. Now, what is x? What is xi minus xj? Now, xi minus xj. If I consider y equal to minus x, consider y equal to minus x. This is what it is, right? The line equation is y equal to 3 minus x. If I remove 3 fundamental, that is the offset only, then it becomes y equal to minus x. Now I can simply replace there. Then it becomes ixi plus yj. This is what it is. So I get back the position vector again if I integrate the velocity vector. dp by dx is the velocity vector. Integration of the velocity vector is displacement vector. Displacement vector, displacement is nothing but displacement. If I consider displacement, this line as, if I consider okay, if dp by dx, if p is the displacement vector and dp by dx is the velocity vector, displacement vector, displacement, if this line, the cross line, what we are getting, the cross line, We are trying to get the length of this line. If this line is represented at displacement vector, if this line is represented at displacement vector, then dp by dx is the velocity vector. If I integrate it back, then I get back the displacement vector. But if I take the magnitude of dp by dx, if I take the magnitude of dp by dx, I get the velocity vector's net magnitude. If I that magnitude, if I integrate it back, I get the displacement magnitude. Up, 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 up. This is third way of getting the line length. Third way of getting the line length. First way was primitive way. Second way was the modern way calculus. Third way is velocity and displacement vector. If I have displacement vector, if I differentiate it, I get velocity vector. If I integrate the velocity vector, I get back the displacement vector. Now, if I have displacement vector, if I differentiate, I get velocity vector. Now, if I calculate the magnitude of the velocity vector, then it won't be any vector at all. It will be algebra. Okay, now if I integrate that magnitude of velocity vector, I get the magnitude of the displacement. Makes sense, right? Magnitude of the displacement is nothing but the length of the line, because line was represented as displacement vector. So magnitude of displacement vector will give the means integration of the velocity vector would give back the magnitude of the displacement vector. This is what we want. Let's try. So now the velocity vector is I minus j. Magnitude is a square root of 2. Integration of a square root of 2 with dx, that is x square root of 2, x into a square root of 2. So length of this line from 0 to any x along x axis, this is x axis, 0 to x, any x is x into a square root of 2. 0 to 3 is 3 into a square root of 2 is the length of this line. Okay, if that is true, then someone can try finding the length of this curve. What is length of this curve? Okay, what is your displacement vector? Xi plus yj, everywhere xi plus yj. If that is the case, then what is your velocity vector? That is I plus dy by dxj. What is its magnitude? 1 square plus dy by dx whole square. Square root is the magnitude. This magnitude dx, if you integrate, you will get the curve length. Impossible. Possible. Try now. So if that is the case, then 1 square plus dy by dx whole square. The circular region x square plus y square equal to a square. Y equal to square root of a square minus x square. If that is the case, then dy by dx is minus xy square root of a square minus x square. If that is the case, then 1 plus 1 square plus dy by dx whole square is 1 plus x square by a square minus x square square root. This is the magnitude. That is a by a square root of a square minus x square dx. Okay, if that is the case, then if this circle is centered at the origin, then I want 0 to a. 0 to a, then I'll get 1/4 of the length. 0 to a. Okay, a by square root of a square minus x square, a I can keep outside. 1 by square root of a square minus x square dx. This integration is sine inverse x by a. Now 0 to a, when a is there, sine inverse 1, that is pi by 2. And 0 means 0. Pi by 2 into a. Pi a by 2 is the length of 1/4. Net length of the circle is 2 pi a. Okay, so this is third fundamental. If I have velocity vector and if I integrate it back, I get the displacement vector. If I have magnitude of velocity vector and if I integrate it back, then I get the net magnitude of displacement, means the length of the line. Because displacement vector talks about x comma y, if you remember, xi plus yj. X comma y represents a point on the line. So displacement vector actually talks about all the points on the line. Magnitude will come as the length of the line. Makes sense, right? So this is the third proof. We'll proceed on it, same fundamental, and we will see more on it, and we'll try to calculate surface area through this fundamental. Anyway, we have calculated surface area many times, but this way we will proceed in the 3D also. Please do support us. +91 is the India country code 9483160610. the telephone number. 9483160610 is the telephone number. Plus 91 is the India country code.